Hello, starting in the name of Allah. So this is a new course. It is about advanced data management. We are starting a series of complete 5 lectures. It will be based mostly on theory. So it is a comprehensive study notes, uh, program artificial intelligence for science and technology. The subject complete name is advanced data management and decision support system, which is basically 2 modules in one subject. We are focusing on advanced data management, starting from the basics. Uh, these theoretical concepts will be more uh, not in terms of to memorize, to learn, understand, and it will be more conceptually. And I'm trying to make all these concepts more easy. So um, I belongs to University of Milano Bicocca, and this is the introduction lecture. So let's move to the second slide. So here we can see the main course content, starting with the introduction and core concepts. And we are covering lecture 2 data models, transactions, distributed data management systems, and distributed computing, MapReduce, and Spark. So let's start with the today's lecture, which is about the introduction and its core concepts of the data management. Okay, so starting with the data, as we said in the start of the lecture, that these values or all the recordings about the advanced data management system will be mostly based on the understanding of the concepts. It is not something to memorize. So that's what I tried to make all these concepts much easy. So the ultimate purpose is to learn what is this actually. I mean, not to memorize in your lot of books and stuff has been written. For more detail, you can read, but the good idea is initially clear your concept. What is this? Okay, what is data? We have seen this word many places. And what is a data management system? So let's start with the word data, where it comes from. The word data, it is basically coming from the Latin datum. So its meaning is things given or thing given. Okay. So it is a collective or sequence of a symbol. So data is not equal to information. We have information also. I mean, some people are using this interchangeably, but it's not usable. They are both two different things. So data, we can say something more in the raw form, and information, which is a transform version of the data. Okay, I mean, which we can use for the uh, our any kind of purpose, whatever we want. But data is not usable, okay, directly. I mean, data is not an information, but information is something which is transformed, okay. I mean, some operations are performed on the data. That after that operations, it becomes the data information. So data must be interpreted to convey meaning. See, they representing the data need to be transformed to have some sort of meaning. Data itself doesn't have any meaning. Okay, in computer science, data is organized as a data structure. Okay, I mean, all of the data we have its format, its operation, each and everything is organized. It's called data structure. Okay, so a representation of a data together with the operations that can be performed on it. Okay, so when we are performing any operation on a data, as I said at the start, so it becomes an information, and now it's usable. It conveys some meaning. It has some purpose. Let's start with the DMAs. As we understood now, what is data? Now we are going to the second topic, which is a data management system. A data management system is a collection of a software enabling. Okay, what software enabling us? Basically, when system comes, okay, so we cannot perform all these operations on an individual level on the computer. I mean, if you take an example, let's suppose reading a binary number, okay, on a machine level. So it is really difficult to read them, write a program for them, and then query them and store your information after query them. So it is quite difficult. So that's why data management system has been introduced. So we call them a DMS is a collection of a software enabling. So what they are enabling, the main three things, okay? Okay, operations, technology, and its purpose. Okay, so we are starting with the operation. So what DMS do? The objective of the DMS, the first one is store data for retrieval. Okay, I mean, this is two things basically. We are storing the data for retrieval. Okay, I mean, the objective of this data storing is to get back. Okay, so what is the technology we are using? Databases. Okay, multiple databases we have. So we are not going into detail right now. What is the purpose? It is persistent storage. I mean, it is a storage which we can through this database we can retrieve the data very easily back. Search, filter data. That is another kind of operation. So when we are searching or filtering the data, so this kind of technology they are using indexes. Okay. So indexes mean in our current data, we don't need the whole data. We need a certain thing. It's called filtering or searching. So the purpose is to fast look up something. I mean, scan the whole data and take it out those things which is required. Perform some computation. Okay. I mean, this is in a kind of operation. So we are computing something. It's more analytical stuff. So what technology we are using? Data processing. I mean, the data level is now increasing. So in the purpose, as I said before, it is for the idea to transform something or to do some analytics. I mean, it is a little bit computation involved, mathematics and all this stuff. Okay. So when it comes to perform some computation, as you know, from the word computation to compute something. So cache expensive results. What does it mean? Cache expensive results means like we are using here caches technology in a computer, which is near located to the processor. The idea is those operations which we are performing frequently, so they are optimizing the performance and help them to retrieve them very fast. Okay, so the purpose is performance optimization. That is the whole idea. So this is the DMS basically providing to store the data, search the data, and perform some computation on them and cache expensive results. So now here we have one of the key idea from this whole things, uh, is to understand conceptually what all does mean, as we are basically going towards the next concept. These are the basics. What is data management system, to create some link with the main topic, which is advanced data management system. So rather than treating databases, indexes, cache, and processing, okay, processing engines. So processing engines is nothing but databases. So they have a certain engines, every database. If it is MySQL, it's a NoSQL, okay, as a separate isolated software, okay. I mean, rather than treating them as in a separate or isolated software, a modern DMS means advanced data management system. We use them as a component of a one unified system. So modern data management system consider them all of them as a one unified system. Either it's databases, indexes, data processing, or caches that must interpret. This is the polyglot persistent philosophy. I mean, all of them should work interoperate. I mean, interoperable. Uh, it should not be work isolated. Okay, as we said, so far in the traditional way, data management system was working this way, but not anymore. As the new concept introduced, it's not new, quite. It's old, but I mean, the idea of the advanced data management system to interoperate all of them, either it's databases, indexes, data processing, or cache. So now let's go in detail. What is modern or advanced mean. So now we are actually introducing or differentiating the two main concepts: data management system traditionally and advanced. So traditional data management system was centralized. I mean, it was the data was stored in one place like MySQL. So you are having only one centralized system where you can store, retrieve the data. So it was a small and slow growing data. I mean, in the scale, it was not that much high and it was slow growing data. So the data was not supposed to be grow fast. It is homogeneous data types. Homogeneous data types is basically, if you take an example, okay, so they were storing a certain type of information. Like if you take an RDBMS, so relational database management system, so they can only store certain types of information, text, okay, JSON or BSN type of information. Uh, sorry, not the BSN or JSON. They are basically stored in the document format, okay? I mean, these two are different databases. So if you take no documents or no SQL, which is one of the example is document. So I mean, document-based database management system, which is MongoDB exactly. So in that there you are storing JSON type or BSN type. Okay. In MySQL, we have a tables. This is the data which having a certain type. I mean, the whole idea here is we are introducing this advanced data management concept in which we can have multiple data type systems. So it's called heterogeneous data types. So what is the differentiation between the centralized, small growing, and homogeneous databases or data types? So the differentiation in an advanced system is the first one, distributed systems. Okay, all of these databases are not centralized. Okay, this is decentralized, you can also say, or distributed. Okay, in a multiple location in terms of location or geography, and also in multiple databases, as it is working on a complete unified system, and it operates. It must operate as I mean interoperate. It should not be an individual or isolated system. Okay, the second thing is, I mean, the advanced data management system is almost impossible to be centralized all data storage in it has be it should be one of the benefit also. If you take an example in the centralized, if you in a one certain geography, your database finished, so everything is gone. But in distributed systems you will have in multiple places your copy of your data, and that's a really good thing in multiple formats. So another thing is, as we said, in the modern database system, that is big data. It is not small or slow growing data. So volume and velocity exceeds conventional processing. I mean, here the amount of the data is very high, or it's very fast growing. I mean, not like in traditional heterogeneous data. As we discussed at the inhomogeneous data types, here the data is not homogeneous, not only text, not only pictures or videos or something, but it could be a combination like text, graphs, time series, document. As we discussed, document is JSON, base and it is a NoSQL, each needing specialized handling. So they should be handled very, very specially. Now let's discuss the era in the keyword in technology or its key idea, like in which era, which technology was exist and what was the idea. So 1990s till 2000, I mean, the technology was big data concept introduced here. And the key idea was like volume, amount of data, velocity, access speed, and variety. Okay, so multiple type of variety data they were trying to introduce here. In 2000s till 2010, the NoSQL or NewSQL concept came. So which introduced the flexible schema horizontal scaling. The idea here it was like after the MySQL, so this was a new type of the data, NoSQL, in it was a very flexible schema in comparisons of the SQL. SQL is a very rigid and static schema, for which if you want to change, so you should have to change the whole schema of the database, and it's called horizontal scaling. I mean, you are horizontally scaling your database. In 2010, MapReduce concept introduced, in which is one of the advanced computation of the advanced data management system. So it is a distributed batch computation. That is the purpose or the key idea of the introductions of the MapReduce. And there's some more things also introduced with the MapReduce. It's called RDD, resilient dataset. Resilient dataset, exactly. So resilient dataset, RDD, resilient data, uh, distributed data. So it is alongside a concept introduced with the MapReduce. So graph frame and all these things are coming in the distributed computing, and all of them. Then the key ideas to uh, process, compute the distributed batch computation. So currently, we are in the era of the polyglot persistence. As we discussed in the previous data management idea, that this all of them is basically working under as in a complete one unified system. Like it is not an isolated software that is not working individually, so all of them get together and work interoperatively. So it's called a polyglot persistence. So the idea of the era of the current time, polyglot persistence, is to combine multiple subsystems per task. So for one task, we are get to gather all of the systems to perform a certain task with massive speed, with high grooving data, and uh, heterogeneous data. And that is the overall idea of advanced data management system. Okay, when we introduced the advanced data management system, so there are three certain important concepts of the advanced data management system which should be addressed. One of them is called reliability, scalability, and maintainability. So all of these three concepts are associated with the, we can say, associated with the advanced data management system. First of all, trying to understand what is reliability, what is scalability, and what is maintainability. Okay, reliability, a system is reliable, resilient. If it is fault tolerant, it continues to work correctly even when fault happens. What does it mean? I mean, if you take an example, a reliable system doesn't mean in the case of failure it should work. No, it's not like that. It's about the fault. The fault which ultimately goes toward the failure in their stopping their system from the fault, it's called reliable. One case is failure, okay? Let's suppose a system directly fail and it cannot re rehabilitate themselves uh, or re-heal themselves again. So we can say it was not reliable. That is okay. I mean, the fault happened during the failure. I mean, going towards the failure, the system does not heal themselves. But the idea here is it could be possible. I mean, the whole world is, I mean, half, it's not a complete. So, but the good system, we call them, that is called reliable. So during happening of any failure, any fault, so they should have to stop and react. It's called reliable. As we have for this have written, so fault is not equal to failure. A fault is a component not working as intended. A failure is when the whole system stops. A reliable system prevents faults from turning into failure. That is the main idea. So we have different type of faults now. I mean, to understand about the faults, and those faults leads to directly into failure. So the first type of fault is called hardware fault, software fault, and human faults. And there are certain type of examples. So the hardware fault is like disk crashes, memory corruption, power outage, or network failure. So these are all kind of examples which comes under the circle of the hardware faults. So what is the traditional solution? Okay, redundancy. Okay, but in distributed systems, more machines equals to higher combined failure risk. Okay, the important concept in introducing here is like redundancy. uh, it could be happen that when certain data can be captured multiple times in case of any such hardware fault, but in distributed systems more machines are located over there in different geographies and in certain even in one place even. So it means there is a higher chances of failure. Okay, failure risk. We said failure means it's causing by a fault. There is a certain type of faults, and those faults are going towards the failure of the system. So it is a distributed system, and there is a higher machine, so there is a higher chances of a uh, or high risk of the system failure. Okay, or risk of failure. So that's why in a distributed concept or advanced data management system, we are introducing the reliability. The system should be reliable and uh, rely on the standards and principles to not go towards the failure in fault tolerate themselves. So software faults are bugs, runaways, processes, service not responding, safety issues. So in the traditional solutions, so they are careful designing, test informal methods. So if you see the human parts are configuration errors, social engineering attacks, so it is in a kind of attack to databases and is a human fault. Okay, I mean third party or an agents. So we are providing training procedures, automate the procedures, which is repeated access control. So the overall idea of the reliability, fault happens, fault leads to failure should have to stop in the system should have to stop themselves. We call this system reliable. And types of the faults: hardware, software, and human faults. Now going towards the scalability. Scalability in simple word means mm, increasing. Okay, a system is scalable if it can cope effectively with increasing load while maintaining reasonable performance. In computer science, there is a famous quote. It's called "where accuracy matter than speed." So here, only maintaining the load is not the idea, but performance also. Okay, if they are maintaining the load with low performance, still the user experience will be bad. So the idea is to maintain the load with a reasonable performance, not a binary property. Requires identifying load parameters in measuring how performance changes with the load. It should be dynamic. It should not be binary. I mean, according to the flow of the data, they should have to understand how to perform and manage the load. So in simple terms, we can say scalable system which can manage the load with a reasonable speed. Okay, so there is a famous example of a Twitter, which is called nowadays X fan out example. So there are two operations. One is called post tweet and view timelines. Like if we are posting a tweet, so the posting of the tweet is 5,000 per second. In view timeline, pushing them onto view timeline is 300,000 times per second. So there are two implementations for this idea. The first approach is like global collection on a timeline view, run a join across all followers. But the problem is 300,000 times expensive queries. So if we are doing on a global collection to push them all on a timeline view, so running the join in a MySQL will be very expensive. What is the approach? On each tweet, push to all followers cache. So we are assigning per followers a cache. So problem, celebrities with millions of followers create a massive fan out per tweet post. So here's the logic coming or the more twist coming to the this example, why they call them fan out example. Because if there's a celebrity and they have a 50 millions um, followers, so in that case it will be also really difficult assigning a cache per user. So here the concept introduced load parameters, and the key load parameter here is the distribution of followers per user. So we need to distribute followers per user. So it's called fan out. So Twitter uses a hybrid system, and the hybrid system idea is, so the first one is using for small common users which have a less followers, and the second one is using for the low followers, and the above one is using for the high followers. So Twitter use a hybrid system. Normal users use approach 2 because we can assign a cache per user, because if a certain person have a 200 users, it's quite reasonable. And celebrities use approach 1. So in that case, that make really sense. So this is how we are managing load parameters, and it's called a scalable system. Now there are two approaches of a scaling, and what is the idea, pros and cons. Okay, one concept we call them vertically scaling, and the other is called horizontally scaling. And they both have some benefits and losses or disadvantages. So vertical scaling means buy more powerful hardware, more RAM, faster CPU. So why it's called vertical? So our system is increasing on a line. Okay, you can also compare with this idea. And what is the pros? So it's simple, no software changes, and the disadvantages is that it's costly. It's hard limits. I mean, it's hardware limiting. Okay. So what is the horizontally scaling? The horizontally scaling concept is distribute load across many cheaper machines. That is in comparisons to the above vertical scaling. So what is the benefit? It is cost effective, scales indefinitely. So you can scale them as much possible, but it is quite complex. It is a disadvantages of the horizontal scaling because of the software architecture. So these are the two concepts of a scaling approaches when we are scaling the system. If it's feasible, we can increase our hardware, but if it is not, so then we should have to manage them across multiple cheaper machines. I mean, horizontally scaling. The last concept, maintainability. What is really important while we are working with the advanced data management system or distributed data management systems, because they should be maintainable, reliable, scalable. Really important concept to know the differentiation between reliability and scalability. Okay, a system can be reliable, but it's not necessary it can be scalable. In vice versa, scalable system, yeah, no, vice versa is not correct. Scalable system must be reliable. Okay, so a reliable system cannot be scalable. But why a scalable system should be reliable? Because if the data is increasing, so they should have to be also reliable in that case, because as we discussed, we are having using more machines, there's a higher chances of a failure risk. So if a system is reliable, it's not necessary to be scalable. Okay, but if a system is scalable, it should be reliable. That is the differentiations of the scalability and reliability. The last concept, maintainability, which is really important. Okay, the important thing about maintainability is typically more harder than the initial development of the complete system. So there are three key principles of the maintainability. The first one is operability, simplicity, evolvability. These are the further sub features of the maintainability while we are dealing maintainability of a system. So operability means keep the system running. That's simple. idea of what is operability means. So it means it should be continuously running, okay, smoothly. So practices good monitoring, avoid single machines dependency, and documentation, self-healing. Okay, so self-healing is automatically coming from the reliability, okay, like fault tolerant, so flash manual control, and there should be some options you can manage the or control them manually. Simplicity, make the system easy to understand. The system should not be very complex, that which cannot be understood by other engineers. In the practices, we should have to minimize accidental complexities. One of them is essential complexities of the system, in another one is accidental, and accidental complexities is really hard to manage using high level abstractions like SQL or manual file operations. And these are the practices we are putting them into implementations while we are developing the system to keep them simple as much as possible. Evolvability, make the system easy to modify, extend. This is really good thing, okay? Evolvability is somehow touching directly scalability. As in the scalability, we said a system should have to cope effectively with the increasing load and with a reasonable performance. So here, if you see evolving your system, like it means it should be easy to modify then, okay, or extend the system. Let's suppose your system is reliable and you want to make them scalable. So according to the maintainability, it should be evolvable your system also. So to easy evolve them or modify them to make them more scalable also. Reliability is now not enough. As we discussed that after the accuracy, speed does matter, or increasing the speed is also important within the scaling at the same time. So what are the practices? Refactor. Okay, refactor often in early. So this is a practice we are applying for the evolvability. Decouple, these are the complete concepts further, but for now we will only say about them uh, directly, like refactor often in early. So it is a main concept using when we're developing the system. Decouple subsystems, so system should be very independent. I mean, independent concepts should not be dependent on each other. When we are modifying one, so the other should not be affected. So this is called decoupled subsystems. Simple system are easier to modify. So these are the methods and practices which we are putting them to make the system evolvable. So in general, advanced data management system should be uh, differentiated in three terms from the traditional. It should be heterogeneous and decentralized. In the big data should be supported. So if you are going to advanced data management, so the system should be reliable, scalable, okay, and scalability depends on which one you are applying, vertical scaling or horizontally. And maintainability is a really important aspect because it costs more than the initial development of the project. Why? Because finding the bugs and all these things is really important. So it should be operable, it should be simple and evolvable. So that is the overall idea of today's lecture. And thank you. If you have any question, you can leave a message or a comment. And this is my first lecture recorded. Hopefully you will like it. Maybe there could be some mistakes or anything. Feel free. You can recommend your changes or whatever you noticed. So thank you.